Hey everyone, thank you so much for joining in. Welcome to Edureka webinars. Now in today's session, we will look into the data structures and the algorithm in Python programming language. Now, as you know, data structure is one of the important concepts in any programming language. These data structures are responsible for holding the multiple values, and it will also help us to retrieve those values. So we'll understand today about what exactly is this data structures and the various built-in data structures that are available in Python programming language. We'll look into the inbuilt data structure, user-defined data structure. We'll look into the algorithms, the elements of a good algorithm, the algorithm classes. And then at the end, we'll also look into the tree traversal algorithm, sorting algorithm, and the searching algorithm. So this is the agenda for today's session. So let's get started. And let's start by understanding the concept of data structures in Python. Now, when I say data structures, so here, when we talk about these data structures, so data structures are the elements in Python which can store the multiple values. And in Python, there are built-in data structures. Now, built-in data structures are the structures, okay, which are available by default in Python programming language. And we also have the user-defined data structure. So in case of user-defined data structure, these are the data structure which is not available by default, but as a developer, we would be creating it. So under the user-defined data structure, we have got stack, queue, tree, graph, linked list, and the hash map. And under the built-in data structure, we actually have got list, we have got tuple, we have got dictionary, and the set. So these are all the built-in algorithms, built-in data structures that we have got in Python programming language. Now, if I talk about this data structure, so organizing, managing, and storing the data, I can say these things are very important, and this would actually enable the easier access and efficient modification. Now, with the help of these data structures in Python, it would help us to organize the data in such a way that it would enable us to store the collections of data, relate them, and even it would allow us to perform the operations on them in an easier manner. So that's the overall idea about this data structure. Now, here, when I talk about this built-in data structures, these are the data structures which are available in Python. So these user-defined data structures, this is what we would create because of the functionality that is available. And here, when we talk about the built-in data structure, as the name suggests, these are built in with Python, which actually makes the programming an easier one. So it would actually help the data, or it actually helps the programmer to use them and obtain the solutions in a much faster pace. So let us understand each of these in detail. So when I talk about the list, so lists are actually used to store the data of various data types in a sequential manner. Now, there are addresses that are actually assigned for this Python list. Okay, and these addresses are assigned to every element on the list, which we generally call it as an index. So the index value starts from 0 and it goes on until the last element called the positive index. And here, when we are working with the Python list, so we also have the negative indexing as well. In case of negative indexing, it goes from -1, and it would enable us to access the elements from last to first. Okay, that's the idea of working with this Python list. And one of the key property of working with this Python list is it has got the ability of mutable. That means once I create a Python list, I can modify the elements inside my Python list. So that's the advantage of working with this Python list. Now, to give you a better perspective on the same, so I'll just go ahead and show you the same. Let me just take you through the coding part. So here, in this case, if you observe the first cell, so I have created a Python list. So in case of Python list, if I want to create it, I just enclose the values inside the square brackets. Okay. So I'll just pass the values inside the square brackets. And if I execute this, so here I'm saying it as x is equal to 10, 20, 30, 40, 50, 60, and I'm enclosing the elements inside my square brackets. And once I've created, if I call the type of x, you should be able to see that the type of this variable x has been treated as the Python list. So that's how easy it is to create a Python list. And here in the slide, we talked about the heterogeneous. So when I say heterogeneous, it would mean that I can have the values belonging to the various data type. If you observe the second example right now, here I'm assigning the x is equal to 10, which is an integer, 25.56, which is a floating point number. This is a complex number. This is a string value. So I've got the values belonging to the various data type. Hence, we would call the Python list as a heterogeneous collection as well. Now in this example, I'm creating a heterogeneous collection of data. Now, if I now display the type of x, see, this is now able to uh, actually say that, okay, this x is also a Python list. So that's the meaning about this heterogeneous. Okay, now while working with the Python list, okay, we can actually add the elements in the list. So if I want to add new elements to the list, then what I can do is I can make use of the functionalities in Python, which would help me to add new elements to my Python list. For example, if you look into my current value of x, this is how the current value of my Python list would look like. Now, if I want to add a new element for this x Python list, I'll say x dot append, and I'll mention the value as hello. Now, once that is done, if I print the value of x, we will be able to validate that the value hello has been added at the end of my Python list. So that's how easy it is to append or add the new elements to my existing Python list. Now, if I want to delete any element from my Python list, I can delete it by making use of the del keyword. Now, to give you an idea, so when we create any Python list, okay, so let me just show you as how we can retrieve it. Then using that concept, I'll show you to delete. So when we create a Python list, the first element will have the position as 0. Second element will be having the value as 1. Third index position is 2, 3, 4, and so on. So now if I say x1, this will return the value at the index position 1, that is 25.56. And if I say x2, this is going to return the value of 6 plus 4j because that is what is present inside this second index position. Now, if I want to modify any existing value, so here the value at second index position is 6.4, 6 plus 4j. Now I'm assigning a new value. So because as I mentioned, the Python list are mutable. That means I can actually go ahead and modify the elements. Now, once that is done, if I display my X, you can validate that the value 6 plus 4j has been replaced with the new value of 99. Okay, that's how easy it is to modify the elements of this Python list. See, I've made use of append to add the value at the end of the list. So this is the overall idea about this append function and the overall Python list. Okay, so the values are enclosed within the square brackets and the individual values are separated by comma. And inside my Python list, I'm having a flexibility to add the value belonging to the various data type. So these are the important properties of this Python list, which we have seen just now. Okay, so moving on, the next data type that we have got is actually the tuples. So when I talk about tuples, so tuples have got I would say that it has got the same structure as the Python list. That means it can contain the values belonging to the various data type, but they are not mutable. That means once I create a tuple, I cannot modify its elements. So because of this property, so we would say that tuples is faster than the Python list. Okay, so let's go ahead and validate it. So here in this example, I'm creating a Python tuple. 10, 20, 30, 45.5, and 4 plus 6j. And I'm also adding one more value, which is a string value. You can see that in my tuple, I've got the values belonging to the multiple data types. If I display my t, this is how the tree would look like. So if I'm enclosing the values within the round brackets, it's actually a tuple. Okay, so just like Python list, even this can hold the values with multiple data types. Now, just like Python list, I can go ahead and access any value by referring its index position. But one thing that you need to remember is this is not mutable. That means they are immutable list, immutable tuple. So if I try to assign a value at zero position with 100, I'll get an error. We'll get a type error which says this tuple does not support the item assignment. And it does not support the append because it brings back to the first property which says that I cannot modify a tuple once a tuple has been created. Okay, so this is the overall idea about this Python tuple. Now moving on, the next data type that we have got is the Python dictionary. Now, Python dictionary is a special kind of data type. Now, this dictionary helps me to hold key value pair. And here, in this case of dictionary, they are mutable. So that means I can modify the values which are actually associated with my Python dictionary once it is created. And if I want to modify something on the index or the key, so at that time we'll have to delete the old key and create a new key. So that's the overall idea about this Python dictionary. So let's have a look into our example. Now, when we talk about the dictionary, see, this is the example of the dictionary. So I'm saying that D is equal to A 100, B 200, C 300. So here A, B, and C that you see right now, these A, B, and C are actually the key values. And 100, 200, 300 are actually the values which are associated with the key A, B, and C respectively. So that is how we would work with this dictionary. And if I want to access any values from this dictionary, at that time, I can simply say it as d dot values, and that is going to return the only the values like 100, 200, 300. Okay, if I say d dot keys, it will return only the keys A, B, and C. Since it is mutable, so I can assign a new key, okay, and reassign a new value. So I've added a new key as D with a value as 500. And this time in this step, I'm modifying the value at an index position. So that's how we can go ahead and create a Python dictionary. So dictionary will help me to store the value in the format of key pair. Okay, now moving on, the next type of data type that we have got is the sets. So set is actually an unordered collection of unique elements. And here, when we talk about this sets, so they are mutable. That means once I create a set, I can modify it. But remember, since it is unordered, so like what it says is we cannot fetch the value by an index position. We can only check whether that value is present or not. So that is the overall idea about this Python sets. Now, when we talk about this Python set has a unique property. So the unique property here is, in this case of Python set, it can hold only the unique values. Like it cannot contain a duplicate value. So it can contain only the unique values inside it. That is the overall idea about this Python set. And I can enclose the values inside the flower brackets. So this is the idea behind this Python set. Okay, so to give you an illustration, so I think I've created above. Yeah, this is an example of Python set. I'm saying it as S is equal to 10, 20, 30, 40, 50. So if I execute this and display the type of S, see, I've got the output as set. Now, as I mentioned, Python set is an unordered collection of data. Now, to prove you this, I'm just storing the S with some random values like 20, 10, 4, 2, 1, 99, 100. And if I just execute this, we can see that the order in which we are getting the output is very different than the order that we have specified in the input data. And that's the reason that we call this Python set as unordered collection of elements. And another thing is this Python set can hold only the unique values. You can clearly observe that in my else that I'm creating, there are multiple duplicate values. I've got I had like 10 repeated 3 times, 20 repeated 1, 2, 3 times. Okay. So in this way, we can see the value repetition 4 repeated twice. Now, when I go ahead and create a set using all these values, and if I just display it, we'll be able to see that only the unique values have been considered for this Python set. Okay, that's the overall idea about this unique value. And here we have got some functions on the Python set, like I can make use of add. So this will perform the concatenation, or this will add that particular element to my Python set, and it will decide automatically as where this new value has to be placed. Okay, so apart from that, we have got the set union, set intersection, set difference. So these are the various set functions that are supported inside this Python programming language under the Python sets. Okay, so this is how it would look like. Now, apart from this, okay, we also have some of the various user-defined data structures. So let us look into the various user-defined data structures. So when we talk about this user-defined data structures, one common question that I would generally get is, so what about the arrays and Python list? Well, when I talk about the arrays and Python list in user-defined function, that's a common question which people has. So in case of array and the list, okay, so we use the same structure with only one difference. So here when we talk about list, so lists allow heterogeneous data element storage. But when we talk about arrays, arrays allow only homogeneous elements to be saved within them. So that's the major difference between the arrays and the Python list. Okay. And when we have got the stack under the user defined function, the stack are actually the linear data structures, which are based on the principle of last in, first out, where the data is entered last will be first one to be accessed. We have got stack, we have got linked list, we have got queues, we have got graph, we've got trees, and the hash map. So these are the various user defined functions that we have got. Okay, now if I want to give you some more information about the other user-defined data structure, we have got something called as a queue. So queue is also a linear data structure, which is actually based on the principle of first in, first out, that is FIFO. Here, the data is entered first, that will be the one that will be accessed first. Now this is built using the array structure, and it has got the operations which can be performed on both ends of the queue. That is, we can do it on the head, tail, or a front back. So like we can do it like the operations like the adding or deleting the elements are actually called as NQ and the DQ, and accessing the elements can also be performed. So we use this concept of queues as the network buffers for traffic congestion management, and it is used in operating system for job scheduling and many more. Okay, and here we have something called as trees. So trees are the non-linear data structure, and this non-linear data structure has the root and the nodes. The root is actually a node where the data originates, and the nodes are the other data points which are available to us. So the node that precedes in is actually the parent, and the node that is actually present after is actually called as a child. So therefore, like there will be levels a tree has in order to show the depth of the information. The last node, we generally refer it as the leaf node, and the trees generally create a hierarchical structure which has its greater implication and its usage when we talk about the real world application, like building the HTML pages. In such scenarios, we make use of trees to distinguish which tag comes under the which block. Okay, that's the idea about these trees. And there is something called as a linked list. Now, these linked lists that we have got in Python, so they are the linear data structure. And here, these linked lists are not stored consequently. Hence, they're not stored consequently, but I can say that they're linked with each other using the pointers. So here, in this case, the node of a linked list is actually composed of the data and a pointer called next. And these structures are most widely used in image viewing application, music application, and even in any other in the much other applications as well. Okay, and we have something called as graph, as you can see. So graph are generally used to store the data collection pointers called vertices and the edges. And these graphs, you can actually call it as a most accurate representation of a real world map. So they are generally used to find the various cost to distance between the various data points called the nodes, and then we will be interested in finding the least path. So many applications like the Google Map, Uber, and many other systems or the business, they actually use graph in order to find the least distance and increase the profits in a much better way. Okay, so that's the overall idea about this graph. And we have got the hash map. Now, hash map is a scenario. Okay, they are actually the same as the dictionaries in Python. So these hash maps can be used to implement the application like the phone book, populate the data according to the list, and many more. So these are some of the applications of this hash map. Okay, so these are all the various user-defined data structure, which means so they are not available by default. In case if you want to require, we have to manually create it. Okay, so that is something that you need to remember while we are working. Now moving on, we have something called as the algorithm. So let us understand what are these algorithms. Now algorithms are actually the rules of the instruction, and these are formulated in a finite sequential order in order to solve the problems. Now these algorithms provide a pseudocode for the problems. So if I want or if I'm interested in writing any algorithm, so these are the common steps that we generally follow. Okay, so first we start by figure out what exactly is the problem. Then we will decide where exactly that we have to start. Okay, now once that is done, we would then we go ahead and determine where exactly that we need to stop. So we need to then understand as when do we come to know that we have actually reached the required solution. Okay, and then we will formulate the intermediate step, and finally we will review the step. So this is what we mean by an algorithm in general. Now here, let's look into the key elements of a good algorithm. If I want to describe some of the key elements of a good algorithm, so this is how the key elements of a good algorithm would look like. Whenever we are formulating the steps, so the steps should be finite. The steps should be what we say this as a clear, and the steps should be understandable. So this is one very important thing that you need to remember when you are working. Okay. And another thing is, so when you are working or when you're creating an algorithm, you should be clear and precise, and you should have a definite description about the input and the output. And as you move ahead, so each step should have a defined output, which depends only on the inputs in that step or its preceding steps. Okay, so that is another important thing that you need to remember. And then here, so we will and then the algorithm should be flexible, and the steps should make use of the general programming fundamentals. So these are the overall elements of a good algorithm. Okay, and then let's have a look into the algorithm classes. Now when we talk about these algorithm classes, here So some of the ways that is recommended, which you can go ahead and work about in these algorithms, are divide and conquer. So this is one type of algorithm class where you will divide the problem into subparts and solve each of the parts. Okay, and we have got a dynamic problem programming technique algorithm class. Now in the scenario of this dynamic programming, it is going to divide the problem into subparts, and it actually remembers the result of the subparts and apply it to the similar ones. And we have the another class of algorithms that is called as the greedy algorithm. So in case of the greedy algorithm, so this involves taking the easiest step while solving the problem without worrying about the complexity of the future steps. So this is called as a greedy algorithm. Okay. Now, while working, so we have got few more illustration about the the algorithms that we have got. And one such algorithm that I've got is a tree traversal algorithm. Now, in the case of this tree traversal algorithm, so trees in Python are non-linear data structure. They actually have a root, and they actually also have the nodes. So the tree traversal refers to visiting each node present in the tree exactly only once in order to update or check them. So that's the overall idea about this tree traversal algorithm. Okay. Now, next we have, if I want to illustrate with this tree traversal algorithm, let me just show you the same. Okay. So here, in case of this tree traversal algorithm, we basically have the in order traversal. We have got the pre-order traversal, and we have the post-order traversal. So you can look into this idea as how it actually look like in case of the in-order traversal. So you'll say what first two, three. You can look into the arrows to follow as how exactly the in-order traversal would look like. It starts with left bottom, and then it goes to the top, the parent one, and then it will come to the right bottom, and it follows the same to reach the top. And in case of pre-order traversal, I'll start from top and I'll take the left below, and then once I complete all the nodes on the left hand side, then I'll cover the right hand part. So this is called as the pre-order traversal. In case of post-order traversal, I'll go in this way, like bottom to I'll complete the bottom, then I'll go one step, and then I'll go to the node in that same level, then I'll go to the top. So these are the various ways in which that I can perform the traversal. Now, apart from this traversal, so we also have the sorting algorithm. So the sorting algorithm helps us to sort the values in a required manner. Now, while sorting these values, we can make use of various methodologies, also known as the algorithm. So we have got the merge sort, we have got the bubble sort, we have the insertion sort, we have the selection sort, we also have the shell sort. So these are the various types of sorting algorithm that we can actually use it whenever we are sorting the collection of values. So if I talk about the merge sort, okay, so the merge sort follows the divide and conquer method. As you can clearly observe in the illustration, in case of merge sorting, we are going to follow the divide and conquer rule. The given list is first divided into the smaller list, and then we are going to compare the adjacent list. And after that, we are going to reorder them in a desired sequence. Okay, that's the overall idea about this merge sorting. Next, we have something called as a bubble sort. In case of bubble sort, so bubble sort, I can say this as a comparison algorithm, which first compares and then sorts the adjacent elements if they are not in the specified order. Okay, so that's the overall idea about this bubble sort. And we have got the insertion sort. Insertion sort picks one element of a given list at a time and places it at the exact spot where it has to be placed. Okay, that's the idea about this insertion sort. And when we talk about the selection sort, so This is the overall idea about this selection sort. Okay. And then we have got the shell sort in case of a shell sort. So this insertion sort, okay, this actually describes about the insertion. So insertion sort, what it does is it picks one element of a given list at a time and places it at the exact spot where it has to be placed. So these are the various kinds of sorting algorithms that we have got, which will help me to sort the values that I have got in my collection. Now, apart from these, we also have the searching algorithm. So these searching algorithms are actually there for us to help us to search for a required value in a given collection. So these are used for to search for or to fetch some elements which are present in a given data set. So there are various kinds of searching algorithm. So we've got linear search, we have the binary search, we have the exponential search, and the interpolation search. So these are the various types of searching algorithms, and all these algorithms are here for us if I want to search for a specific value. Okay, then yes, then when we talk about the algorithm analysis, so here these are the algorithm, like these are all the algorithm analysis that we generally take up. We have got the a priori analysis. So in this case, all the factors are assumed to be constant and do not affect the implementation. And when we talk about the posterior analysis, the actual values like the time complexity or the execution time of an algorithm, space complexity are actually gathered in the scenario of this posterior analysis. Now, before I end the session, I also want to show you about the tree traversal algorithms implementation. See here, if you look into this scenario, okay, so this describes the tree traversal algorithm. So what I'm doing is this is a class, okay, so I'm just going to create the node and the structure right now. And once I do that here, this describes the in order traversal. So in case of the in order traversal, as you have seen earlier, I'll first go to 4, then 2, followed by 5, then 1 and 3. So this is how I can perform the in order traversal. So this describes the pre-order traversal. In case of pre-order traversal, it is 1, 2, 4, 5, 3, which is exactly same as what you have seen earlier. And this describes the post order. So this describes the post order traversal. And this is the implementation of the merge sorting. Okay. And this is the implementation of the bubble sorting. And here we have got the insertion sort. So these are the various kinds of sort that we can actually use it to sort the list of values that are with me in a required manner. So with this, we come to the end of today's session on data structures and algorithms in Python programming language. I look forward to seeing you next time. So thank you so much, everyone. Take care.